In the next example, we're going to be looking at some trig expressions that simplify to an algebraic expression, not as a single number or as a single trig value in terms of just x, but it will be a trig value in terms of x, or an expression of that. So what we're looking at is we're going to find the cosine of the arc sine of 2x plus the arc sine of cosine of x, which we're set up to apply a cosine of the sum. So that means we take the cosine of the first angle, which is arc sine of 2x, then we have to take it times the cosine of the second angle, which is arc cosine of x. Then we have to go minus sine of the first angle, which is arc sine of 2x. Then times the sine of the second angle, which is arc cosine of x. Now we've got to interpret all these things end up meaning. Remember, when you see an arc sine, it says find the angle whose sine value is 2x. So I'm going to end up drawing a couple of different reference triangles. One triangle I'm going to draw over here. Now, using these clues, it says we're going to find the angle whose sine value is 2x. And that's a sine value of 2x over 1, which means the opposite side has to be 2x, the hypotenuse has to be 1, and we're going to go ahead and find that angle. This is the angle it's referring to. So what is the cosine of this same angle? Well, in order to find the cosine, we need to know the adjacent side here. Well, to find the adjacent side, it's the hypotenuse squared minus the opposite side squared. So it's really going to be a 1 minus 4x squared and then the square root. So what I did is I used a Pythagorean identity just to kind of spell it out. I did a 1 squared equaled something squared. That's going to be our x value. I don't want to use x probably. Let's just say our adjacent leg squared plus 2x squared. So 1 squared is 1. We're going to find our adjacent leg squared by adding to it 4x squared, subtracting your 4x squared. That would give you your adjacent leg squared, but we just want the adjacent leg, so that's where the square root came in. So alright, so we're supposed to find the cosine of the angle whose sine value was 2x over 1. So that is going to be the adjacent leg, which is the square root of 1 minus 4x squared all over the hypotenuse, which is 1. We got to take that times the cosine of the arc cosine of x. Now this is going to be a second triangle because we're referring to a different triangle than just 2x. So here's my second reference triangle. I want to find the angle whose cosine value is x over 1. So the clues are its adjacent side has to be x, its hypotenuse has to be 1, so that will help us find this opposite side over here. It's getting kind of pinched over there, but it's going to be 1 minus x squared and then the square root. So it says go ahead and find the cosine of the arc cosine of x. So kind of did a little extra work over there to think through it the whole way, but we're going to take the cosine of the arc cosine, and those are inverses of each other, so it should just be the value of x. And if we look at this, we can see that the angle that they're referring to has to have a cosine value of x over 1. Then go ahead and go find the cosine of this angle, which is x over 1, or simply take it times x, for x over 1, minus. Now we're going to go ahead and find the sine of the arc sine of 2x. So this is what I'm focusing on first. Go to the inside. Find the angle whose sine value is 2x. Well, I'm going back up to this reference triangle. This is the triangle whose sine value is 2x over 1. And we want to find the sine of it. So again, if you take the sine of an arc sine, they should undo each other. So what is the sine of this angle that was described by the arc sine of 2x, which is, again, just 2x over 1. Now over here, it's a little bit more interesting. It says go ahead and find the sine of the angle whose cosine value is x. So now I'm down in the second reference triangle. This is the triangle down here that I just highlighted, whose cosine value was x, or x over 1. So what is the sine value of this same angle? Well, that's going to be 1 minus x squared over 1. So times square root of 1 minus x squared all over 1. So if we simplify this the best possible way, typically we'll put our x out in front of the radical. So it's x times 1 minus 4x squared. then minus, and then this is going to be 2x times the square root of 1 minus x squared. Okay? So that's our final solution for this problem, and now we're going to look at the second one. If you want to look at the textbook, they give you some substitutions that you can make for finding those angles. I find them somewhat helpful, but not enough where I want to mess with the substitution of it. So you're welcome to look there. This one is a sine of a difference, so we want to take the sine of the first angle, which is the arc tangent of x. We want to take that times the cosine of the second angle, which is the arc cosine of a half. Excuse me. Then we want to make sure we subtract the cosine of the first angle, which is arc tangent of x, times the sine of the second, which is the sine of the arc cosine of a half. All right. Oh, looks like I forgot the x here, so let's put that in. The first expression says to go ahead and find the sine value of an angle whose tangent value is x. So again, think of your reference triangle. The clues that it's given you is that its tangent value has to be x over 1. So that means when I draw this triangle, the opposite side is 1, the adjacent side is 1, which means the hypotenuse is the square root of x squared plus 1. So if we find the sine of this angle that this arc tangent is asked us to look through, which is this angle here, then the sine value is simply x over, or the opposite over the hypotenuse, which is x squared plus 1. We got to take that times the cosine of the arc cosine. So we looked at these a little bit earlier in the first example. So if you take the cosine of an inverse sine, they should undo each other, and it's equal to a half. But if you want to, and you're going to need it anyway, draw your second reference triangle. It's giving you clues that the cosine value of the angle, whatever angle you draw, so there's the angle, its cosine has to be equal to 1 over 2. So this one is one of our friendly ones. It's our 60-degree angle. So if you take the cosine of the same angle that they just asked you to do the arc cosine of, you get back to 1/2. So now we got minus. Now we're evaluating this expression. Find the cosine of the angle whose tangent value is x, or x over 1. And that's my reference triangle up here. What is the cosine of this angle? Well, it is 1 over x squared root of x squared plus 1. So it's 1 over the square root of x squared plus 1. Take it times the sine of the arc cosine of a half. So find the sine of the angle who has a cosine value of a half. So here's the angle that has a cosine value of a half. Now what is the sine of the same angle, which is square root of 3 over 2? So take it times the square root of 3 over 2. So we have the hard work done. Now it's just a matter of doing a little simplification. So we're going to have x over 2 times the square root of x squared plus 1, and then minus the square root of 3 all over 2 times the square root of x squared plus 1. And now it's a matter of rationalizing. So it's going to be x times the square root of x squared plus 1 all over 2 minus square root of 3 times the square root of x squared plus 1 all over 2. And I'm not going to go to the time of writing it over a common denominator, but we could also do that. So I'm going to pause here for a second and see if I got everything the way I like. Glad I paused that because I got in a hurry and I was taking top and bottom by the square root of x squared plus 1 from square root of x squared plus 1. And the squares will cancel, but I'm still left with x squared plus 1 on the bottom here, and another x squared plus 1 down there. So it's going to be a little bit different how they write these, but I'm going to write it as a single denominator, x squared plus 1, minus the square root of 3 times square root of x squared plus 1, all over the common denominator 2 times x squared plus 1. And what we can do with these two is we can go ahead and factor out our square root of x squared plus 1 and take it times x minus the square root of 3 all over 2 times, shoot, you can even distribute that. There's going to be a lot of different variations of how you can write it. and the finished version, but this is one form of the finished version of the type of solution that you could have. And like I said, there are other versions of this as well. I can come back and look at probably 3 other different ways of writing it, but I'm going to stop with that. And that gives you the general idea and feel of how you're asked to complete those types of problems.